What's up everyone? This is Dariusz Kalmarczyk, co-founder of NG Poland, JS Poland, Angular Master.dev and Workshop Fest.dev. Welcome back to the JavaScript Master Podcast. Today we've got a special guest from Warsaw, Poland, independent consultant, software architect, speaker, trainer and co-founder of Architektura na Froncie. Ladies and gentlemen, Tomasz Ducin. Hi Tomasz, how are you today?
I'm fine, thank you. And how are you?
Thank you so much. I'm great. So, for those who don't know you yet, please tell us about yourself.
I'm Tomek. I've been working in the industry since 2007. When it comes to my interest, I'm interested in cinema, movies, theater, and a little bit of woodcraft recently. That's a lot of fun. When it comes to programming, I've been working in technologies such as Java, Python, PHP as well, and for over a decade so far, I've been also working in like wide JavaScript ecosystem, everything related to JavaScript frontend and this kind of stuff.
You mentioned PHP. What do you think of PHP these days?
I haven't been connected to PHP for over 10 years so far, so my knowledge about PHP would be very much outdated, I believe. But I think that it has its place. Maybe it's not that, let's say, architecture-wise complex such as Java or .NET, but certainly interesting applications have been built with it, such as, well, Facebook, for instance. So, well, yeah, it's just one of many languages that are used. No hatred towards it, although sometimes some jokes are funny, but like you can make fun of every language, including JavaScript first and foremost.
Definitely. Let's back a little bit. How did your adventure in programming started?
Maybe this will not be a very interesting story. Well, in high school, we've had computer science classes, and one of the tasks we've had to do was actually doing a Christmas card that was written in Turbo Pascal. And basically, we were about to create some animations and some, visual audio effects, some musics. And I started playing with it, and I found it so enjoying just creating a Christmas card that I thought it will be kind of interesting to dive deeper into it. But actually what is more interesting in my case is how I could have gone out from the programming industry, and that was during my studies. So I went to computer science at uni, and I fell in love with theater, and I spent most of my time, including weekends, trying out some roles, playing, traveling through Poland, and doing the shows with my theater. And at some point, I even got engaged in a well-recognized theater that basically traveled the whole world and exists for over 40 years so far, I guess. And I had to decide, what am I going to do with my life? And it was a time where it was kind of difficult to match doing programming and theater because both were basically too much, time-consuming. And when I get to this, let's say, mature theater group, I found out that it's going to be really challenging to have a kind of normal life when you don't become an alcohol or drug addict, and you basically don't break up, relationships over and over and over again. So I decided, I'm going to quit the 7-year theater adventure and basically focus on programming, going back to programming, and here I am.
Amazing. So our topic for today is partial hydration, server components, and evolution of web applications architecture. Could you briefly describe the terms and explain how they relate to the web apps architectures?
server components is a term that has been coined in React tooling, though it's something that could have slightly different names and will probably get adapted in other tools as well. And it's been already adapted, like, for instance, with Quick or other tools. And partial hydration is something that is more, let's say, universal. So server component is basically a React component that is going to be strictly rendered, built, executed on the server, and is not going to be alive on the front end. So basically, you're going to build something that is static, and the front end is never going to refresh it. So it's kind of slightly different than what server-side rendering is. And so basically, you're going to have a division of your components into server components, the ones that are purely static and rendered on the server, and client components. And client components, let's say in short, they would behave like the components we know from SPA, single page applications. They will be interactive. You're able to basically click a button and expect that there would be some interaction, there would be some page reaction to it.
So this means that we are taking our front-end components back to the server?
Yes, because for instance, if we take a step back in history, for instance, when we have been creating web apps, well, actually some applications still do that with Python, PHP, or Ruby. You're basically delivering static HTML to the browser. Browser is going to create the DOM, but your PHP, Python, or Ruby isn't going to introduce any interactivity. So any interactivity you can include there is going to be purely client-side. So the intriguing part here is that React used to be primarily client-side tooling, and now it's getting back to the server. Lots of questions may arise, like why? Server components, due to the fact that they're never going to be alive in frontend, they're capable of using server-side APIs like querying the database directly or reading your files on the server directly. And thanks to it, server components introduce something that is called async components. So basically, instead of a function that would use client-side hooks like useState and useEffect, basically, if you create a React component that would be responsible for basically data fetching, you'd have to combine a couple of hooks and first and foremost understand how does useEffect work, what is its semantics, etc. And now on the server, you might have an async component that is basically an async await JavaScript function, and you can basically await a database call and populate it. So we couldn't do this on client side because if an async function is frozen, it's basically awaiting for some promise to be resolved, you cannot return it because you don't have the result yet. So basically, maybe your application would not freeze because JavaScript is, event loop based and is asynchronous, but your function would not immediately return something. So if you were waiting for anything to be displayed, what would you display? If your function is frozen, that's the problem. And async await in JavaScript is crafted in a way that the function will not return unless all the awaits are basically done. And the same limitation applies to the server, but hey, if the server is processing your request, then it's not a problem that you don't return something. The user is basically waiting slightly longer for this. So the problem, something that could be a problem on the front end, is not a problem on the back end. So it turns out that it's way more convenient to, for instance, create server components using async await. So we get rid of useState, we get rid of useEffect, and basically await your calls. So this is one of the pros of the approach. But the thing is, you can mix the server and client components within one application. So you are within one stack, and if your well, the whole paradigm is focused on the concept that you don't need interactions inside your whole page. There might be, for instance, big pieces of text, big pieces of data that you don't click, you don't change anything there, you don't type anything using your keyboard. You basically need just some certain amount of pieces that you will interact with. So why would you basically make them alive, make them interactive? Why would you force React to create the virtual DOM to make them interactive? Like, it requires CPU, it requires RAM. Why doing it? So you basically introduce interactivity only for the certain pieces, and those are the client-side components. Everything the rest is could be server components. So basically, you're trying to do data fetching as simple as possible on the server side, and whenever you need reactivity, you fall back to, let's say, the old React way of doing things. So you try to get the best of both worlds, kind of like this. And when people say that PHP is back, well, actually, to some extent, yes, because we are going back to the server. But on the other hand, well, in PHP, you could not introduce reactivity itself because PHP does not exist in the browser, right? So you would have to use some JS, jQuery, or React or whatever. But PHP is not responsible for interactions.
Now we know what server components are. So what is hydration?
Hydration is something that has been around since server-side rendering. So when Next.js was created, or Gatsby was created, or even when Angular introduced server-side rendering in Angular Universal, hydration was already there. So with a traditional SPA application, the thing is, when the browser downloads receives the HTTP response with your, let's say, mostly empty HTML document, first you have to fetch the JavaScript, the scripts with the framework, with the application, and start executing it. So in SPAs, the application was being built within the browser from the scratch, from the very beginning. And with server-side rendering, when you download the HTML, it already includes the content, the final content that you need. So you get a static HTML. By static, I mean it's kind of dead, so there is no interactivity there. But when your HTML is already displayed to the customer, to the user, and you want to start playing around with clicking buttons, typing some things into your inputs, there is not yet any JavaScript that would process it. You need to fill your static HTML, your dead HTML, and make it alive, make it interactive. And this is hydration. So basically, you need to go through the DOM that you already have, and you need to fill it with the event handlers, basically the functions that would start reacting to whatever the user interactions could be. So for instance, what Next.js is doing is it receives the HTML from the server, and it also receives the JavaScript bundle that includes what the application is supposed to have, and it starts creating the virtual DOM. So in SPA, you have nothing, then the React starts to creating virtual DOM, and then you have the content. And with server-side rendering, you get the document with the content. You start creating virtual DOM as you did before, but now React is trying to compare whether the HTML that you've had and the HTML, the virtual DOM that is trying to build now, do they match? If they don't match, and this is mostly some kind of your mistake within the code, it will throw an error because they should match. And yeah, this is hydration. But it's not only about React. For instance, what Angular is doing the very same thing. And in recent version of Angular, in Angular 16, there was improvement introduced called non-destructive hydration. So what Angular Universal has been doing until version 15 is that when you got the HTML with the document, then Angular bootstrapped within your browser started to create the output. And the problem was that they removed entirely the HTML that you've had and client-side build it from scratch. So for a short amount of time, there was a blink that you haven't seen anything. It lasted for a very short time, but it was not very, user-friendly. So what they introduced in version 16 is that instead of removing and creating from scratch, they're basically trying to patch the thing so that there is no, white blinking of the page. But all in all, hydration is something that all frameworks that support any kind of server-side rendering and interactivity will have to do. Because whatever the server does will have to, the client will have to take the control over what the server has sent already. So hydration is somehow the process of getting the control over what the server has sent.
So could you explain how the new approach is different from what we had before? What is the improvement?
The improvement is that not all your components are going to be hydrated. So we are not doing full hydration as with previous versions of Next.js or current version of Angular, but you're only cherry picking the parts of your application that you require interactivity for. And the thing is, if you're going to introduce interactivity, you need client-side JavaScript code that will fuel it, that will support it. And now, if you bail out from interactivity for certain parts of the application, you need less JavaScript. So you need less JavaScript to download, and you need less JavaScript to parse and execute, and basically to slow down your runtime. So in very short, that's the thing. So we can expect vast improvements in not only how fast the page loads, but also how fast the application interacts. But in order to better understand the whole concept, it would be valuable to go through the history of web applications. How did they evolve? Because then it will be way clearer to see what are the exact differences. So I would suggest we would step back to multi-page applications. So what we've done 20 years ago, kind of. Then whenever the user wanted to access a page, open a page, then there was an HTTP GET request to the server, and what the user received was a page with the full content. Now, you might be missing some JavaScript or CSS scripts, fonts, other assets, and images, etc. So there were more HTTP GET requests, but all in all, when the page loaded, you've had the whole content already. The problem with multi-page applications was that whenever you wanted to do any kind of interaction or move to another page, you had to reload the page, reload the whole page, right? So there was another request to the server, and the server would have to process the database queries. It had to fill the templates, do basically all the stuff. Even though you just needed to change one piece of the application, the whole page had to be reloaded. So it was nice that when you actually get something, you have the content, but there were lots of unnecessary reloads. Then in 2003 or 2004, depending on how people claim, Ajax was introduced. Yeah, it's already 20 years old. So Ajax didn't remove any of those problems, but it reduced the scale, the size of the problem. So there were still lots of requests going on, but you didn't have to reload the whole page. You just reloaded only a tiny bit of the page. But still, the server was responsible for too many things, including templates, including supporting the user session, etc. So, for instance, if you wanted to allow the user to draft something, create something, you couldn't store it in the browser, right? In this approach, you had to store it in a server session, for instance. And then single-page applications came. So the main improvement behind SPA is that the server had way less responsibility to do. So the server could focus only on accessing the databases, making sure that the business rules and the logic are handled properly, and basically return data, for instance, as JSON, and all the stuff related to the user, or maybe vast majority of concerns related to the user, are going to be held within the browser. And as a consequence, the server has less things to do. For instance, no templates, no storing the client data. Actually, we could have moved this into the client, into the browser. And as a result, as a consequence, the server had to use less resources. For instance, if you're running a massive scale application and you don't need to process any templates whatsoever, you need less servers, and that is basically saving money. So this is the killer feature of SPAs. This is a very big pro, but SPAs introduced quite a bit of drawbacks as well. So one of them is the lack of SEO. Search engines, when they try to access a JavaScript application, theoretically they're able to execute your application in some kind of a virtual sandbox, but it's way more resource consuming to execute the whole JavaScript instead of basically parsing your HTML head meta tags. It's just text. So if the search bot is about to basically parse your HTML or execute your your JavaScript SPA application in a virtual sandbox, come on, they just don't do it because they don't care. And so one problem is SEO. The second problem is that our navigation history buttons stop to work. When you click the back and next button out of the box, they're not going to work. You have to support them explicitly. So this is kind of a breaking change. And from the user's perspective, probably the biggest change is that when you open an SPA-based application, a single-page application, then at the very beginning, you see a blank screen or a spinner, and you have to wait maybe half a second, maybe a second, maybe 3 seconds until anything loads. And this was not the case with MPAs. So these are the problems. And now, many businesses tried out SPAs because they are probably the most obvious choice right now. But if somebody have to have good SEO, then they couldn't go into SPAs. For instance, Amazon is still a multi-page application, so they're doing basically the architecture more or less the one that we've been doing 20 years ago, and they're fine because this supports their business requirements. But some other businesses decided that, okay, we'll give a try to the new approach, server-side rendering. And what server-side rendering allows is that we will start our application as if it was a multi-page app, but once the initial page is being given to the user, then the application is going to be interactive just like an SPA, and this is basically what Next.js is doing, and this is where full hydration is taking place, the thing that we've spoken. So with SSR, server-side rendering, the problem is that when you're accessing a page, a document, all the database queries and processing, all the server stuff, is going to take place at request time. So it's not going to be executed prior to what you've been doing. So potentially when you're waiting for the response, you're also waiting for the database queries. So what people figure out is if your content doesn't depend on you being a certain user, or if your content is not changing every second or isn't, very frequently changed, then we can pre-render it. Why not doing it before so that the user would waste way less time? And this is static site generation. So for instance, things like Gatsby. So basically, if your content is universal, doesn't depend on time, doesn't depend on user, or even if it changes across time, but it doesn't change very frequently, we can pre-render it, that static site, generation. A slight improvement to static site generation is incremental static generation, which basically means if your content, let's say, updates every hour, like in the news applications, then each hour your pre-rendered content is going to be, again, re-rendered. But whenever the user accesses your pages, they will basically be served with static HTML files, and that's it, and JavaScript bundles as well. So this is the point in time where we were kind of half a year ago or maybe a year ago. And the new thing here is the server components and the partial hydration, where we actually try to get the best of both worlds. So it's not that we have either SPAs or SSR or SSG, but we combine them all together. So when you want, you have static site generation because your page is universal. When you want to have something including content per user, then you do server-side rendering. That means depending on who you are, what is the user, you would have a different content being sent. And when you don't care about pre-rendering and you can basically hand over the rendering stuff to your browser and you don't care about, web metrics and speed, then you can just move the stuff to client-based applications. And the thing is, when you do hydration takes time. So you need to load the bundle, the browser needs to load the bundle, it needs to parse it, it needs to execute it. And the thing is, when you have server-side rendering, the user can see the content very fast. But the problem is, when the user clicks the button that is immediately visible, sometimes they have to wait quite a bit of time until there is actually any reaction to the button because of loading JavaScript, parsing JavaScript, executing JavaScript. And the thing is, if you force the browser to do less of this JavaScript, you would have faster interactions. So whenever you care about web metrics, like especially core web vitals, the server components are going to be a huge improvement because you'll have less JavaScript to process. Hence, the web metrics would be improved. So it was quite a long one from me, but I believe it's important to understand what were the changes, what we wanted to achieve here. So at this point where we are, it could sound quite complex, but actually we get the flexibility that within one stack we can decide whether we prefer SSR or SSG or SPA or MPA, all within one application, one stack. So that's kind of the improvement.
The million-dollar question, why would someone choose the new approach?
A typical situation in a company where developers might be interested. Oh yeah, there is new version Next 13. Let's rewrite our, let's say, React application into React Next.13. And the business asks, why would you do that? So the thing is, what you can expect from business perspective from it. If you go with server components, then you can expect that server components are not going to be interactive, and all components are server components by default. So by default, you get no interactivity. So only when you put a special use client, just like use strict in JavaScript, just you need to put a label use client. Only then you get interactivity. And then, as I said just before, less JavaScript is going to be processed, so you would have improved metrics. So if your business relies on good web metrics, especially when they care about SEO, this is the improvement you're going to get. So for instance, if you're a company which sells enterprise software, so some software that other companies are going to use, and you don't have massive scale of users, but your users are going to be, very specialized, like specialist in some domain, then they might not even care whether your application loads in a second or half a second or 3 seconds, because their company bought the software anyway, so they don't care. But if you have a massive scale of users And whether you wait 1 second for page load or half a second of page load, or when you click something, how long do you have to wait until something gets processed on your mobile device? This makes a difference in massive scale applications. So why would someone choose the new approach if you care about web metrics very much? So there are two metrics that there are three core web vitals. So that's largest contentful paint, first input delay, and cumulative layout shift. First input delay is going to be replaced by interaction to next paint, but let's leave it aside for a moment. So it's important to understand what do those metrics measure actually. So largest contentful paint is the time that you need to wait between the moment that you start opening a page and until you see the biggest block of content that is going to be displayed. The biggest block of content could be some text, it could be an image, but basically when you walk into a page, the biggest thing that you see is going to be this largest block, and it's considered to be a good measure if you have less than 2.5 seconds. But the thing is, those metrics are measuring end-to-end stuff. So this includes not only rendering, but it also includes how long is the server going to process it, what network circumstances there are currently, and all the things that the browser has to process. So when we have single page applications, largest contentful paint might get hit very, very significantly, because first we get a blank page, then we have to load the JavaScript scripts, then we have to parse them and execute them. Only then we know that there is some HTTP GET that we further have to send in order to get any content through a JSON, and only then this JSON can be processed, for instance, by virtual DOM, and only at the very end we would get some content displayed. So largest contentful paint is hit very, very significantly with SPAs. So we can improve this by moving basically to server-side rendering or static site generation. So this is the improvement for LCP, largest contentful paint. But if we have SSR or SSG and you get a whole page with all the content, and then you need to hydrate the full page, then you have already the content displayed, but you have lots of JavaScript to process right now. So when you click something, your page might seem to get stuck for a while, and this could be some kind of somehow disruptive for the user. So if you want to remove this disruptiveness, then you need to push less JavaScript to the client, and that's why people might choose the new approach. So basically improving the first input delay metric, which means the time, the distance in time from the moment where you actually click something until the page can react to it. So if you had lots of JavaScript that was scheduled in event loop in the queue, waiting to be processed, and you click a button, then you'll have a callback at the very end of the queue. So the shorter the queue on the event loop, the faster your your interaction will be processed. So that's one reason to choose the new approach. The second reason, and I believe is even more important, is that if you started creating a SPA application and your business finds out, okay, we need to improve our metrics because we want the users to see our pages faster. So this means we need to improve our largest contentful paint metric. And the problem is, if you have your entire application based on the setup that is purely an SPA and you want to move it into SSR, then, well, you need to choose a different framework or completely rewrite your setup, which is doable, of course, but could require a significant amount of work. And if you start with, let's say, universal framework, just as Next.js, or hopefully one that Angular will shortly become as well, you are able to choose between SSR, SSG, or SPA, or MPA within one stack. And the thing is, when we start an application, we don't know what our business requirements going to be within 1 year or 2 years, or even especially within 5 years. And the thing is, if the business requirements change according to those performance stuff, you don't have to change your framework. You can do it within one stack. And this is kind of, future flexibility, which I think is the true value behind this approach, is you can shift things from the server to the client within one stack, and you're kind of future-proof when it comes to the changes of like the requirements that change when it comes to your performance. So this is what I consider the reason for choosing the new approach. Because let's say like this whole approach is still pretty fresh, pretty new. So some things are still in alpha, but it's just a matter of time until they're stable. And imagine, let's say next year you are about to create a new app. And let's say you decide to make it as a single page application. Why would you choose a single page application if you can have a stack that allows you to have single page application, multi-page application, SSR and SSG? And basically you can move things around without the need to completely rewrite it.
If a company asks why we need to rewrite the entire application, what is the most appropriate answer?
First of all, it depends. What do you have right now? Let's assume that the most frequent answer would be that we have an SPA. So I don't think that there would be a significant improvement for most existing single-page applications that have been already built, because one could say, oh, it's just some improvements when it comes to largest contentful paint and first input delay. This might not be a factor important enough to migrate to such approach. But for new applications, well, why would you choose something that is older and, let's say, more limited? So that's the thing. So if your business really requires speed, performance, and the optimizations of the metrics, they're probably running SSR in some way or in some extent already. So for existing applications, especially the core like enterprise applications, I don't think it's going to be a good choice for now. It won't pay off. But for new things, certainly it's something that people should at least consider because of the flexibility.
So security, performance, and flexibility.
Security is one of the factors that still needs some clarification because some features are in alpha. What I'm aiming at is a feature called server actions. And actually, well, kind of one of the problems behind specifically React is that there is some like blurred line of responsibility between the React team and between the Next.js team. So it used to be that React team was responsible for React, and now it seems like the React team is kind of giving the direction that Next.js team is implementing. So the responsibility is kind of blurred, and one of the problems that they need to focus more currently is when you have an application, one single stack that you have both on the client and the server, the way you develop the application is changing the way you think about the application as if there was no boundary between the client and the server. And technically, we know there is. But the applications try to resemble as if there was no boundary. So there is some, let's say, area for potential security threats. For instance, like in practice, many developers who have been working only on single-page applications are used to basically fetching JSON objects and displaying them on the client, and that's basically it. So many developers might have not even heard about what is script injection or SQL injection. And now, if those developers will evolve within the ecosystem and move to server components, then they have to pay attention to potential, for instance, SQL injection. So if you get some parameter from the client and send it to the server across a server action, you need to make sure that you don't, introduce any threat to your database. And for anybody who has been working on the server side, it's kind of obvious, but hey, let's realize that we have a whole new generation of purely front-end developers who might not even know what is SQL injection. So, like, theoretically, it's nothing new, but in practice, we have a whole generation of people that we have to teach, like, hey, there is something like this. Basically, pay attention to what you push to the database. What queries do you make? Like, drop database and this kind of stuff. Security is one thing that, in my opinion, is not emphasized enough in the documentation where it comes to basically front-end only developers. So I wouldn't also recommend going in this direction right now because of the alpha features, because it's pretty new to all of us. But within 1 year, who knows, I think it would be mature enough to try it out in big applications.
Yeah, but we can agree that the security is the most important problem and is very visual for a business.
Yeah, it's a critical factor.
Critical.
Yes.
So it is correct to say that server components are a hybrid approach where both server and client render the view.
Yeah, exactly. Because in SPA, you have purely the client. In server side, everything is started on the server and you get the full interactivity on the client. And now you can choose. You can choose between what lives only on the server and what is going to be alive on the client. So yeah, this is kind of a hybrid approach. And yeah, the biggest pro of this approach is that you don't have to choose this upfront, but you can move between those hybrid elements of the architecture, like move something from the client to the server if you don't need interactivity or vice versa.
So isn't the new architecture actually not a purely new architecture, but rather a mix of everything that we have before, plus the new server components?
Yes, kind of, because if we think about it, we do have everything that we've had in this evolution that I described previously. So if you, let's say, want to have a landing page within your enterprise application, then you create separate pages with separate SEO headers, all this kind of stuff. So you have a multi-page application, just like you've had 20 years ago. But then, if you need any interactivity, then you introduce the client components, and then your server is not responsible, like your server doesn't have to pay for introducing the interactivity. It's the browser, it's the user who's going to pay for electricity for running, this features within your browser. Your server doesn't have to do it. But also, if your landing page is kind of static, you can render it upfront because it doesn't depend on the user. It doesn't change very frequently. So we can leverage SSG. And if you log into your, let's say, account and you have a dashboard, in order for the user not to see a lot of spinners around, like for instance, you log into a bank account, which is an SPA, you see kind of 3 spinners, 4 spinners, or 5 spinners until you can see anything, which is kind of funny. You log in and you see nothing meaningful. And leveraging SSR, even if the server caches something within, like on the server side, it could be improved, but you can already see the content. So it is like, on one hand, it is a new architecture that's value is actually taking the best of all the worlds that we've had before. So MPAs, SPAs, SSRs, and SSGs. Yeah, that's the key behind this new architecture.
Okay, all this sounds interesting, and we are improving. But if we are going back to the server, isn't it taking a step backwards?
Well, there are some people in the web claiming that, oh yeah, we're getting back to index.php and so on. So some people consider taking a step backward. So it really depends, what do you want to achieve? Because if the only thing that you want to achieve is to render the things on the server because Next.js 13 is the new buzzy thing that everybody is speaking about, it has no sense. It makes no sense. So no. But if you have in mind that, for instance, you want to improve your LCP, or if you want to improve your FID, or next year when first input delay is going to be replaced with interaction to next paint. But basically, how long do you wait for interactivity, the web metric? If you have this in mind, then no, it's not taking a step backward. By the way, the difference between FID, first input delay, and interaction to next paint is that FID, basically all web metrics are trying to be the least technical, and let's say they try to measure stuff from the least technical perspective and mostly from the user perspective. So for instance, a few years ago, we've had time to interactive, TTI, and what that means is whenever your JavaScript stops processing stuff from the scripts it loaded, here you have interactivity because JavaScript's event loop is, the queue is empty, so whatever you click, it could be processed straight on. But the thing is, when you see a page, when you're an actual user and you click something, sometimes user will wait 5 seconds or 10 seconds. Basically, they're reading something or they're looking for something until they click actually something. So pages are different, and measuring time to interactive doesn't reflect user behavior at all, because time to interactive ignores the user entirely. So what first input delay is doing, it's measuring the time that the user has to wait for the first interaction. But how about the second or the third or the fourth interaction? It's still ignored in FID. So what interaction to next paint is doing is making a next step in the evolution of web metrics that is basically measuring all time that the user needs to wait for all the interactions. So it's kind of a sum. So not only the first, but all of them. So if we think about it, the evolution of web metrics is basically trying to reflect the user behavior as much as possible and measure the user experience. So time to interactive, interaction to next paint is going to be resembling the user behavior even more, and is going to reflect, like server components are going to like benefit in this metric even more.
I have to ask this question. If we don't want to have the downsides of single-page applications, and for this reason, we are moving to the server, and so many apps nowadays are single-page applications, would you say that single-page applications were a mistake?
Historically, no, but there is a... Well, this topic should be discussed more and more, because there are pages which should never be SPAs. So the problem in engineering, like in general, is that if you have a trend, people follow the trend without understanding it, or at least without understanding it much enough. And SPAs were basically popular. And I think they're still very popular and are the default architecture for web apps nowadays. And many applications that tried out SPAs had to move back to their server implementations because of, for instance, bad SEO, because of prolonged time for the user waiting for any kind of content. So some businesses made the mistake of moving from multi-page applications to single-page applications, indeed. So in general, it's not a mistake. It was just a next step in the evolution, but certainly, yes, some pages should never be SPAs. And my concern is that if people pick up the server components, or in general the partial hydration approach too soon without understanding what they want to achieve, then we would have basically the same situation. So there would be applications which should never implement this architecture, but they will do it because many other people are doing it anyway. So, for instance, if you have a big enterprise application and you are sure that you don't care about those web metrics because the companies are selling some kind of access to other companies, then the employees are not going to look for alternatives. So, well, you don't care. You don't care. So you would have to pay for the infrastructure when you have Next.js because it is run on the server, so you have to pay for it. In case of SPAs, you don't have to pay for it. So there are always drawbacks. There are always some cons, and we have to be aware of them. So yes, such as SPAs were a mistake for some companies, then I'm afraid that partial hydration and server components, which are definitely more complex, are going to be a mistake for some other companies. But this is how people are. We basically follow trends, and I wish we understand the pros and cons of each approach better.
Where applications are getting more and more complicated.
Yes, definitely. One of the criticism behind React that I kind of accept with is that when you program, like when you develop applications in React, it's very kind of satisfying that you understand functional programming and you understand referential equality and all those optimization stuff, and you care for your stable references. But somebody would say, hey, do you have to have a PhD in mathematics and functional programming in order to do web apps? Like, is it really a hard dependency to be so smart in order to do just web applications? And well, it's kind of like reasonable. The question is, are they becoming so complex for a reason or not necessarily? But yes, I think like one of the drawbacks behind server components is increased complexity. Yes.
Let's go back to the server components. They were introduced in the recent version of React. It is possible for developers to use them now in their React applications?
So it depends what are their React applications. If they are using pure SPAs like Create React App or Vite or any other client-side only version, no. Because the fact that React supports something doesn't mean then the browser will be able to use it. For instance, React supports now React is supporting streaming the components. So basically, instead of doing it via traditional HTTP when you wait for the whole response, you are streaming the things in a certain order. So you start with the top components, then you stream down the nested components, etc. You need a lot of code to be able to process it the right way on the server side. And if you don't have something like Next.js or any alternative, well, there is a feature that React as is supports it, but you have to have an infrastructure on the server, or at least the implementation that would do it. So if you wanted to use it in a client-based application, you'd have to implement a lot of code on the server side, which actually doesn't make sense. So if somebody is using pure SPA React, they would have to use a server-side framework. But if people are using Next already, then they can just upgrade to the most recent version, and here they are, yes.
Are there alternative implementation of partial hydration to React server components?
There are some existing alternatives already, such as Quick, that you have been hosting, Miško, already, so I'm not going to say too much about it. Let's just refer to certain episodes. But in very, very short, what Miško and the Quick team claim is that they're doing no hydration, and that quick is a resumable framework. So in very short, it means that whenever the server sends you something, it tries to send only the HTML so that you get only the content that you want to see. And only when the user start any interaction, for instance, click a button, only then the client would download a very small piece of JavaScript from the server to support it. So there is no hydration in terms of, supporting the virtual DOM, etc. And you're not doing it up front, because still with React's server components, even if you don't hydrate the full the whole document, just let's say the half of the document, then you are doing it eagerly. So when you download the page, you hydrate only, let's say, half of it. You're doing it upfront, eagerly. So even if the user is not going to click the button, you are hydrating anyway. And what Miško and the team decided is that they are postponing it to make it not eager, but lazy. So we could argue whether it's hydration or not. The Quick team calls it that there is no hydration, but still they need some JavaScript to support interactivity. So whatever we call it, they're doing it lazily. Another alternative is something that I'm really looking forward to is Angular, maybe 17, maybe 18, we'll see. But Minko has announced that the future versions of Angular, since they have already full-featured SSR with this non-destructive hydration, they're looking forward into partial hydration as well. So we will see what their model is going to be, but I expect that it's going to take them some time because it's for React, it was kind of a revolution internally. So I believe it might be a kind of a revolution internally within Angular as well. But yeah, I think partial hydration is going to be, well, I don't want to say the next big thing, but I'm pretty sure that the frameworks will want to support it because it's basically yet another optimization and improvement. So yeah, some alternatives are already there, some are announced, but I believe that within 2 or 3 years, it will be basically a standard.
Before, if we had in SPA, we didn't require any server at runtime. Now we need a server. Isn't this a significant drawback?
It depends on your business and company, but generally speaking, yes. So with SPA, the only server that you need is basically a file server or a www server, where basically a hosting. So even if you had a, hosting where you upload files via FTP, the file transfer protocol, that would be kind of everything that you need, because you just need to download HTML, JavaScript, and CSS files, and that's it. But now you will need a server that runs in runtime. So yeah, this is a drawback, not only because some people will have to learn how to maintain those servers, but also the company will have to pay for it. So the main feature behind SPAs was that you could reduce your server costs. And now if you're moving back to the server costs are increased back again. So you need to calculate whether it's worth the money. So for some businesses, yes, it will be worth the money, and for many businesses, it might not be. So it depends.
It depends is the best answer always.
Yeah. But the question is, what does it depend on? So yeah, is the money that you need to spend on maintaining the servers and running them, is it worth the benefits that you can expect from improving your web metrics?
Since we are speaking about drawbacks, are there any limitations to this architecture where we have client components and server components? What should we watch out for?
Oh, yes. Yes, there are limitations, and it depends on the specific implementation of this approach. I can relate to React's implementation. So the thing is, when you have a client component, you can have interactivity. When you have server components, you can access the server APIs, but generally speaking, not the other way around. So for instance, when you have a server-side component, you cannot use useState or useReducer hooks because they maintain your component state in runtime. And the thing is, your component is not going to be interactive. And interactivity, technically, results in a mechanism that whenever you change your state, you have to refresh your component. And that's basically reactivity from one perspective. So if you're never going to be interactive, you're not going to use useState or useReducer, you're not going to use the state hooks. So they're not allowed there. Moreover, if you have side effects that are running within your component, so in Angular and ng on changes, and in React the equivalent would be useEffect or useLayoutEffect. When you need to react to the changes of your properties or of your state, and you would execute a side effect, the thing is, since the component is not going to be interactive, you're not going to use effects as well. So they're disabled here. So, and all those hooks that rely on state or effect, your custom hooks, are as well disabled. And in server components, you're not allowed to use any browser APIs, which is kind of obvious, but there are quite a bit of things that you need to remember. And there is also a new feature that is like, it's a technical feature. It's called a use hook, or some people call it use pseudo hook. So all in all, instead of using the use state thing, you can use a promise, which is going to do a little bit of black magic that is yet, let's say, allowing you to write less code in your client components, but is kind of, increasing the complexity and understanding on what is going on. So you can use a promise. You don't await a promise, as it relates to the thing that we've spoken before. So with async awaiting, like making a component async in the server is not a problem. Even if you wait, basically the browser will wait longer for your response. But in a client component, it would be a problem because the function will be freezed until your await gets resolved. And let's say that they wanted to have async components in the client side, but they couldn't use async await because of the problem that we described. And for this reason, instead of using async await, they introduced a little bit of black magic that is called use hook. So you can basically use a promise, which is when you freeze on the promise, this component is going to continue, which is kind of not very obvious. It's going to continue and return what you have before the promise is resolved. And when the promise resolves, it's going to run again for the second time and return the actual content. So it's going to be basically a next feature that might replace the need for use state plus use effect. But still, in server components, you cannot use it. So you need to remember quite a lot of stuff that you can use on one side and cannot use on the other side. So, for instance, if you can use this use thing in client components, you cannot use it in server components. And in client components, you cannot use the async components that you have in server. So when you're listening to it, you could feel like, oh shit, what the heck is going on here? So the first impression could be like this, that there is a list of things that you cannot do on the left-hand side, and there is a list of things that you cannot do on the right-hand side. The nice thing about it is that they all make sense. So on the server, you cannot use the browser API. On the browser side, you cannot use the server API, which makes sense. So async components are on the server. Use hook is on the client, so you cannot use them the other way around. So it does make sense, though. At first, it could be kind of confusing. And there is also something called shared components. So it's a component that could be used both on the client and on the server. And don't get fooled. It's not taking the best of both worlds. It's taking all the limitations of both worlds. So you cannot use the server API, you cannot use the browser API, you cannot use the use hook, you cannot use async components, etc. So a shared component is actually something that cannot be specific to the server nor to the client, but mostly the so-called presentational components. So basically HTML plus CSS with no logic whatsoever. That's what shared components could be. And these are the components which you could move from the server to the client with potentially no overhead whatsoever. But yeah, they have the most of the limitations. So to sum it up, yes, if your application is somehow split between the server and the client, which have completely different environments, you cannot do it without limitations. But it depends on the implementation, how big those limitations will be.
What do you consider the most important in terms of those server components and partial hydration approaches?
The most important thing that I find here is that business requirements change sooner than we can think of it, and if we are able to use a tool stack that allows us to make changes that would be easier to make in the future, that's the most important thing. So I'm not sure whether I'm going to be a fan of React Server components or Angular Server components or Quick or anything else, but I believe that partial hydration is basically the next step forward that is going to take the web by storm, just as SPAs did. Probably I'm going to become a enthusiast of the simplest approach of all of them, because I don't want to fight the framework. I want to basically use it and be friends with it. But yeah, the promise of relatively simple changes that need to be done to move something from the server to the client, this is the most important thing. But yeah, as we said before, for the new projects are going to benefit from it the most. By the way, when SPAs were introduced at the beginning of the 2010 decade, or maybe 2015, whatever, then at that time, there were lots of multi-page applications that were not yet migrated into SPA. So let's not expect that there will be, a new wave of those server components applications soon. It will take time until the business will actually walk into it. But after a decade, I believe that partial hydration is going to be so obvious that everybody will know what it is. But it depends on which implementation will rule the landscape.
So what is your prediction for the future? Should developers learn those new things?
Yes, certainly. So I believe partial hydration is going to be the future, as I said. I'm not sure which implementation exactly, but this one certainly. It's important to understand not only how does your JavaScript code work. Maybe it's not the most important thing to become a master in how does use effect work, how does use state work only, but also how does the browser work? What is the anatomy? What is the flow when your application gets loaded? For instance, dear front-end developers, you should get familiar with the performance and application tab in your browser's DevTools. You should be able to analyze what are all those measurements there, and what do they mean? How to make practical use of them. So when you analyze what is the flow when your application loads, this is where you can actually see all the benefits, and only then you can evaluate whether a change will make you benefit from it or not. So yeah, I believe developers should learn about the hydration and first and foremost about the performance in the web, because somehow SPAs, maybe I don't want to say that SPAs ruin the performance, no, but it's significantly reduced the user experience when it comes to loading the initial stuff and breaking CO. So yeah, let's make it good back again.
What advice would you give to people who are starting their career in the software world today? And what for those who are old-timers, especially regarding the AI?
The AI. Yes, that was actually something that I was thinking of. So, for the newcomers, the question is really, really hard, because what AI is currently able to do, sometimes it has hallucinations, sometimes it will not tell you the 100% correct answer, but still, if it generates 20 lines where you have to just fix one line, still you have 19 lines for free. So this does improve performance. And for instance, I'm a heavy Copilot user, and I really make heavy use of it. Also, I use ChatGPT when it comes to creative work. So I wouldn't rely on GPT when it comes to, let's say, any things like analytics or calculation. But if I want to phrase something in a nice word, I just ask, hey, give me 10 hints how you could say it. And I'm treating GPT as kind of a sparring partner when it comes to speaking or writing, because there are some phrases which sound so absolutely brilliant, and I would never think about them. But anyway, all this AI that we have right now can replace very, very, very repetitive tasks in general. We could doubt about the quality of the answer, but still, some things can be made way faster. But AI, as for now, is not going to give the direction or suggest the direction of your architecture. So this is something that is not automated, and I don't think that this will happen anyhow soon. So for instance, if you have your application where you use A, B, C, and D tools, the tools can write you the code. But when there is a question like, should you use A or X or Y or Z tool? It depends on your business, and this relates to business requirements, to the design of your application, the architectural drivers, and your limitations. And AI is not very helpful in this area at this point. So I would suggest actually both the newcomers and the old-timers to invest in learning architecture principles and the design as much as possible. And somebody could say, oh, if I'm a newcomer, I'm not able to learn architecture. Well, to some extent, yes, but the sooner you start thinking in terms of what is pull-based, what is push-based, what is implicit, explicit, what is static, dynamic, if you start thinking in terms of design, the sooner you start thinking in terms of design, the sooner you'll realize that for a certain class of problems, there is a certain class of solutions, and I believe that somebody who has been programming for 3 months is able to think logically. So I'm a big fan of teaching and learning architecture from the very beginning, because why not? Come on. Like, if somebody is able to think logically, they're able to also think in terms of architecture. So this is something that AI is not going to replace soon, in my opinion. So I would suggest to invest in your design and architectural knowledge and skills as much as you can, because this is, first, universal, and second, doesn't seem to be replaceable soon.
Would you agree with me that AI is simply a tool?
Yeah, exactly. Or like a smartphone has been a revolution, but still we have lots of work to do. Even that we have smartphones, we have navigation, GPS, etc. So there is still a lot of work to do. I would suggest people to think of this, let's say, AI revolution in a similar way to a revolution that we both, Darek, had in around year 2010. Before that year, more or less, we have all been, like most of us, have been writing CRUDs, the create, read, update, delete things. And around year 2010, like previously Ruby introduced those CRUD generators, then CRUD generators appeared in PHP, Java, Python, and now hardly anyone is writing CRUDs because we can generate them. Does it mean, and people were really afraid, oh my God, what are we going to do? We are going to lose our job. And what happened? Business said, okay, generate those stupid CRUDs and work on business requirements and business logic, client logic, persistence, scalability. Generating CRUDs opened the door for big data. Big data opened the door for machine learning and cloud and etc. And now we are speaking about AI because we have so big processing power thanks to cloud and big data that we can speak about it. And what I think is that the boring, repetitive, shitty tasks that we sometimes have to do, they're going to be automated more or less but this will only open a door to more, let's say, more specialized jobs or more specialized work that we sometimes do, but there will be a more need. So I believe that the boring and odd work will be automated, and it will yet increase the requirement for highly specialized professionals. But as I said, I would say learn design and architecture as much as possible, because maybe the code will be generated for you, but you need to give the direction.
What kind of person is Tomek?
I'm a person that likes to help others, and I like nice atmosphere when I basically spend time with people or when I work with people. So the constructive and nice atmosphere is important for me. I like when people can trust each other and can feel comfortable. So this is both in private life and in professional life. I would say this is one of the most important things for me. So I don't feel well when somebody is kind of, either discriminated or there is some problem that they cannot overcome.
Do you have some hints for us regarding self-organization?
Something that works for me is narrow focus. So instead of trying to do too many things at a time, focus on just a few things. So maybe I'm not very proficient in this, but like I'm holding a couple of various lists of the things that I should do, and the list never ends. And there is always more things that I wish I could do, and I have not enough time. But the important thing is, like the way I see it is, we're always, like professionals, we're always going to have less time than we need to have. And if you think in terms of not being able to do all the stuff that you want to do, then you can burn out more easily. So what I try to do is I'm trying to focus on the things that are, on one way, important or urgent for the first thing, and the second group is important things. So I try to decide what are the important and urgent things that I should do today. And if I reach this thing, I'm satisfied with myself. And this satisfaction is very important in the long run, because I don't burn out if I experience satisfaction, on a regular basis. If I cannot achieve this, then there is lack of satisfaction. But I try to, kind of measure how many things can I do within a day, so that I achieve the satisfaction and I don't burn out. And as a consequence, you need to learn what you can skip, maybe not ignore, not get rid of, but if there are some things that you really should do or you have to do, what are the things that you don't necessarily have to do? So your time is precious. This is the way I try to think about it. So focus on only few things, try to achieve them during a day, experience the satisfaction. Like, this is really, really, really important for me. Especially, as you said, I also consider myself as a hardworking man. Without the satisfaction, I couldn't carry on like this. So I try to limit as much as I can, so that I experience the satisfaction, so that I have strength and motivation, maybe first and foremost motivation to continue and to be happy, to do what I want, to do what gives me joy. Yeah.
How about your work-life balance?
I have a quite specific situation being an independent consultant. So sometimes I have a month where I have, let's say, 6 consultancy meetings and 2 or 3 trainings, which is very, very intensive for me, like extremely intensive. But other month I could have 1 gig because I just decide that I need to take a break and basically concentrate on it. So maybe majority of people who basically work full-time couldn't apply the strategy, but in order, again, not to burn out, I'm treating my free time, or the time with my family, or the time when I basically ride a bike or travel somewhere, whatever, I treat this as a slot of my time that is important for me. So it's not that I'm going to, do this and this and this and this. And if there is something left, then I'll take care about myself. No, taking care about myself is just like sleeping or working is taking care about myself is something that should take some amount of time within my weekly calendar, because if I don't do it, then a risk of burnout is again becoming higher. I'm mentioning burn down so much because at some point in time, I think I could have gone through one, so I know how it feels, and it's not a nice situation to be in. And if you don't allow... there is maybe one more thing. My work requires being creative quite a lot, because it's not only about understanding the things, but teaching requires a teacher to create a content that is engaging, that is interesting, that is funny, that is somehow different than everything that you've seen, because it makes it interesting that it's different from visual perspective or the way how you introduce a thing. And I found out that it's very difficult to be creative when you don't have any spare time. If your brain is working the entire day, then there will be basically no creativity. So what I'm also trying to do is do kind of silly things, like doing some work in the garden, doing some woodcrafting thing where my brain, I don't do any intellectual work, so that I can focus only on, kind of repetitive manual things, because then my brain is kind of sleeping. But, without this spare time for the brain, you will get no creativity. Like when I was doing this Architektura na froncie course, I have found out that when I was working in my room, in my cabinet, I was kind of trying to figure out some things, what is the best way to introduce a topic. And when I went for a walk, like immediately 2 or 3 minutes after going out from my house, I had basically a flood of ideas. I was flooded with ideas just because I fucking went outside of my house, and it's kind of magic. And you need to, if you allow your brain to have a rest, you're going to be way more creative. This is which works really, really well for me. And it's also very satisfying. So I like what I do. And this is a, never-ending, it's a loop, never-ending story.
2 books you would recommend to our listeners, one technical and one non-technical.
Maybe let's relate to your previous question. What would I suggest other developers? So if you consider the word architecture, just as many people out there in the internet consider like folder structure, which has barely nothing to do with architecture, I would recommend to read Simons Brown Software Architecture for Developers, or something like this, or Architecture for Software Developers, something like this, by Simon Brown. If you're experienced with architecture per se, maybe it's not going to be very useful, but if architecture as is not something that you feel very well or very familiar with, it's going to be mind-blowing for you. So it's going to introduce a completely new way of thinking, especially when we've said about the AI that is not going to replace us, etc. So it's going to bring you a new way of thinking about why should you decide one thing or why should you not decide one thing, to basically make conscious decisions, to manage the decisions, to be able to take a step back from a decision, to manage risks. Everything when it comes to software development and software engineering. So Simon Brown, Architecture for Software Developers, I believe. And when it comes to a non-technical one, the 2 books, kind of psychological books that I read and had quite a huge impact on how I work, how I behave. I don't want to say one book because I find both of them very, very interesting. So one of them is Robert Cialdini's. Not sure what is the exact English title, but it will be something like Influence, Persuasion and Psychology. Psychology of Persuasion, something like this. So Robert Cialdini, a very interesting book where the professor doesn't teach us how to persuade people, but he rather shows what is the mechanics behind persuasion, so that when somebody tries to trick us, we will see what they are doing. Or even when you're listening to some people in the TV or politicians, you will see what exact technique are they doing. But also when you see that you do have some value in what you do, for instance, with consultancy or doing trainings or any kind of developer advocacy, you can increase your being successful by following some techniques. So Robert Cialdini is he's very well known for being an expert in this field. And the second book is David Rock, Your Brain at Work, and it's a completely different book. The author describes some situations in some difficult situations. For instance, you need to send a document which you haven't started working on within 1 hour from now, and you need to really focus on it. But you're thinking about all the things that you have experienced from the very morning, so you cannot focus on it. And your printer breaks up, and somebody calls you, and you lose some more time, so you're under more and more and more stress. So the author describes such situations, and he shows, let's say, two branches. One is that you basically fall with panic, and what are the consequences of it? And he shows an alternative branch where you try to apply a certain strategy. I know it's difficult to apply those strategies, but if we never try to apply those strategies, then there will be no improvement. So he shows what the person could have done at that moment to basically stimulate our brain to shift the focus from emotions to, for instance, something that is important. When you still have this 1 hour, for instance, when you have 1 hour, turn off your phone. So simple things. There is a lot more, but it helps you in difficult situations, and it helped me quite a lot of times already. So it's David Rock, Your Brain at Work.
Tomek, thank you so much for this great, amazing discussion. I have no words. Thank you.
It was a pleasure for me to be here. So thank you very, very much for inviting me, and I appreciate that very much.
Thank you so much, and hope to see you soon. You are invited as a speaker to NG Poland, JS Poland. So, looking forward to it.
Thank you very much, Darek, and wishing everybody to have a great day.
Thank you so much.
See you, and
bye-bye. Thank you all for tuning into today's episode. If you found our conversation insightful and wish to continue being a part of our journey, please consider subscribing to our podcast. By doing so, you won't miss out on any upcoming episodes, and it helps us continue to bring you meaningful content. Remember, every subscription, like or share truly make a difference. Until next time, stay curious and keep listening.